Hey guys, I'm Hanan and today I'll be doing the recitation for debugging. This is an essential skill to have as any area we code we would need to know how to debug. This skill will not only be helpful in this course but in other programming based courses as well. So let us begin. For this recitation video, we will cover common debugging scenarios and then we'll provide you with some general coding tips, after which we'll go through how to visualize the images and speech dataset, and finally we'll go through how to debug with breakpoints. There are many different types of debugging scenarios. Some of the common types of debugging scenarios are listed here. First one is where your code may be running properly, but the accuracy of the model of which you're training may be very poor. Another type of common scenario is where we get some sort of complex error thrown by the code. These messages are usually pretty complex and many times it is very tough to understand the error message that they provide to us. Then another type of debugging scenario is where the entire code works pretty well, but the model training time might be taking forever to train. For example, maybe your entire model works well, but the training time per epoch is like 2 to 3 hours, which shouldn't be the case for any of your homeworks. To mitigate some of these debugging scenarios, we will talk about some of the good practices that can be implemented to ensure that we can reduce these scenarios where we would need to debug. The first important good practice is to consolidate all your hyperparameters into a single area. This can be done with a single config dictionary or a YAML file where you can put all your hyperparameters in this dictionary or YAML file and basically change the values from there directly. This way you will not need to always search for your hyperparameters in the file, as usually the notebooks or the files given to you for your homeworks, especially the starter notebooks, are always pretty big and it is always tough to find the hyperparameters you want to change. So basically consolidating all your hyperparameters in one area will not only help you improve your efficiency in doing your application studies, but also make it easier for you to understand where you are going wrong as well. For all your homeworks, especially the part 2s of your homeworks, we will be giving you a config dictionary to which you can always save your hyperparameters over there. Another good practice is to ensure you write some test cases. Usually your homeworks will be very long and it is tough to go through different functions for debugging. So usually all your functions will be linked with each other. So if you get an error in one area, that error could be from a different function which is just connected to the function or the cell block you just ran. For these scenarios, debugging process takes a lot of time, which is not an ideal case. For that, we should write the test cases for the different functions to test them out individually. This will save you a lot of time in the long run. We initially give some high-level test cases for the initial homework 1 and homework 2 so that it can be easier to debug. However, you will still need to make your own test cases for different functions to test out their capabilities. Some good practices for writing your test cases are first by printing the type and shape of the important variables to see whether your model is giving the correct dimensions for your variables and gives you the correct type as well. The second good practice is to slice and print only a segment of the high dimensional variables, as most of your dataset will be having high dimensional variables where it will be tough to get any useful information from. For this, it is just recommended to print only a segment of these high level dimensional variables to gauge out whether you're getting correct values for your from your model. The third practice would usually come when we use different type of data augmentation techniques, in which we might need to visualize the data to see how the changes to the data are made. These data augmentations usually have different hyperparameters which needs to be tuned, and it is very important to visualize them to ensure that we do not put too heavy or too light augmentations on the data itself. We do have a short demo code in the end of the video to show you how to visualize your data using the matplotlib function. Finally, it is recommended that when you're done with debugging or fixing up your entire code, to run the entire model or the iteration only one time to ensure that everything works smoothly, as there are times when people train like for 30 to 50 epochs initially itself and find that there is an issue with their test functions and are essentially forced to rerun their entire model again from scratch, which basically means that they had wasted their time and their computer resources as well. You are running Jupyter notebooks to do your homeworks, in which case many students do, as we provide the starter notebooks to be done. Using print statements for debugging is a very crucial way to help you debug in this case. You can use this to print your shapes and type of the variables to ensure you can debug your way through errors such as shape mismatch or type errors. You can also control your print statements with the help of a debug flag, which you can set to true when you are debugging and want to see the shapes, types, etc. for all your different type of important variables. And once you finish basically debugging, you can set your debug flags to false, which will ensure that it won't print any of your debugging information which you needed. This is a more efficient way to debug rather than just commenting and uncommenting your print statements every time, which is pretty redundant in nature. Also, when you are running your code from a Jupyter Notebook or a Google Colab, sometimes you might accidentally have run a cell twice, or you might have ran the cell in the wrong order by mistake. This is always hard to keep track of essentially, but it usually means that there is nothing wrong with your code, and you just basically need to restart your kernel and rerun everything from the beginning. That should basically help run everything smoothly again. Now let us proceed to show you how to visualize your image and speech dataset. So let's begin. Yeah, so now we'll talk about how to visualize our image dataset and speech dataset. Basically, we should know that we will be working on homework 1, homework 3 and homework 4 with speech dataset, while homework 2 consists of image dataset. So it's important to know how to visualize these two type of datasets images. So these two types of datasets, so it'll be easier for us to go and do the homework as well. We'll also show you how to do some sanity checks as well for your homeworks. So let's begin on that aspect of it. So first thing first is we take our data from basically I would say from Fashion MNIST dataset from the Torch Vision library. It just consists around of 60,000 training examples and 10,000 testing examples, while each image is like a 28 into 28 grayscale image, and the associated label is basically one of the 10 classes within it. Yeah, so we will be playing with even larger data sets, but this is just a small toy example for us to inspect individual data samples from a bigger data set. So yeah, let's first go and load our data set, the Fashion MNIST data set. And yeah, after we load it, I would say we'll do a small sanity check to see if everything works smoothly. Just shift enter, and as you can see, after doing that, we can see that the type of data set is basically it's a tensor type, which is totally fine. The shape of the image is 1 into 28 comma 28, which basically is in line with what we wanted, and the type of the label loaded is basically integer. That's also totally good because we know it's between like 0 to 9, and value of the label loaded is basically 9, so that's totally fine. Moving on, let's try to print our image within let's say the Jupyter notebook. So when you print it, you're just going to get like bunch of random values. There is no way a human will be able to visualize this unless you have a supercomputer in your brain. But yeah, basically it's impossible for us to visualize these numbers by ourselves, so we need to know how to visualize it. So for that, we will be using something called matplotlib. Over here, if we just use basically I imported matplotlib.pyplot as plt, and I just did plt.imshow of that same image, and when I just shift enter it, yep, so you can see ankle boot, because basically the label is 9 for us, and it was just giving us ankle boots for that. The reason why I used img.squeeze is basically because it's a 1,28 into 28 image size. I just wanted to convert that to basically 28 into 28 to basically show the image over here. So that's why I just use squeeze over here. Other than that, everything will work smoothly if you just use plt.imshow for seeing your image. Moving on, so this is just a small exercise for everyone, so you can just try visualizing the 10th image in the dataset and its label and what type of cloth is it, or you can do it for whatever other type of image and data set or label, whichever you like. This is just for playing around or having a feel for the homework for you. So now moving on, so now let us proceed to visualize our speech data. Basically this first cell block just helps me create any I would say audio file for us, and just saves that as a .wav file for me. So I just create my own WAV file, and here is my WAV file generated essentially. After that I just need to import torch audio, and basically to play the song I just need to do ipython.display as ipt, and then just ipt.audio, and then just put in the file path of your WAV file. And when you do that, it will essentially help you play it within the Python area. This is just going to be a random noise generated because I just generated this right now. So it's just random noise. That's totally fine. Now we can just print our shape of the audio and our sampling rate. So for this, our and our 16 into 10 to the power of 3, that's our sampling rate, and basically the shape of the audio is just 16 into 10 to the power of 4. That's totally fine. We know that because the audio is about 10 seconds long, so that's okay for us. We can generate our MFCC features. Basically MFCC features, we will learn more about it in homework 1, and how is it important for it and all that. So I just generate my MFCC features here. Now basically with these plot commands, we can just basically plot our MFCC coefficients against frame. This basically helps us visualize our speech dataset, and it's always important to visualize our speech dataset, especially when we're doing data augmentation such as time masking or frequency masking. So when we do techniques, it's always very important to see how it it's very important to visualize it to see how it affects the data set. We just basically run this block and we can visualize our speech data set with that. So again, we just use imshow from matplotlib to basically get that thing sorted out. And yeah, this is again a small exercise for everyone to be completed. Basically you can visualize or analyze any of your WAV file. We just gave one small example over here. You can do it for whatever you like. Basically you can play the audio, load the audio, obtain its MFCC features, and then plot the diagram, similar to what we just did right now. And finally we just gave you a small matplotlib cheat sheet which has basically all the necessary command lines for you to use to let's say plot anything you want.